Hello everyone, my name is Eddie Chiang, and today I'm very proud to present Chess in Python. So this is my submission for the ENCMP programming contest. This code is done entirely by myself. The inspiration behind this was just that I really like chess. I've been playing it since I was very little, and it's something that stuck with me for a very long time. Okay, so I'd like to start with a bit of a showcase of the current version. So let's move on here to Spyder. And if we run the code and let's play a game, you can see it takes moves in algebraic chess notation. For the most part, it only uses things within the ENCMP course scope. And actually, I think the only thing that isn't is loading these sprites of these pieces here. So there really is no software that's required. It really is just Python, NumPy, and Matplotlib. Each color, red and black, it is a list of NumPy arrays. All right, with that, we have our very first version. Yeah, so this version was very bare bones. It loads the position of pieces. It only moves pawns, and even then, pawn movements, they're not very polished. They're not finished either. But it was just a baseline, so I could start coding other pieces based on my code for pawns. One major issue I was coming across was organization. I was getting lost a lot in my own code. I had the mindset of only put what's absolutely necessary. And that's what actually discouraged me from putting notes for myself. But I will say I regret not doing this earlier. This is actually so useful. Version 2. Using the code I already had for pawns, I coded the other pieces. If there's two pieces that are going to the same place, by default you must disambiguate by their files. Now, if their files are the same, next up in the list is rank disambiguation. And if and only if they're both still ambiguous, then you may use double disambiguation. So my initial approach was to do with the one-line approach. I just need to do this one parameter and the whole thing will run fine. That parameter ended up being so long and so difficult to read. It was really confusing. I was really trying to just do it in one step. I was really just trying to create this parameter and then have it be done. But the solution was actually to take it a bit slower. Let's define what ambiguation actually is. So if we have two rooks, so the first rook can move to the square, and the second rook is the same. Let's put them in a list. Now, we can already see when there's more than one rook, then now we have an ambiguous case. Now, do they have a different file? By default, if they have a different file, we do file disambiguation. What if they have the same file, but they're in a different rank? Well, next up in the list would be rank disambiguation. And of course, at the end, we have double disambiguation. All I really had to do was take a step back, think about it in a simpler way. Don't rush to your goal, and keep it simple if you can. Okay, so moving on to version 3, we have castling and we have en passant, but that actually wasn't the highlight of version 3. Everything was much more organized, easier to find. I thought of the functions like functions for math. It makes it, for me, it made it a lot more intuitive. It made it easier to work with. On the left here, we have two parabolas. We can see that they're identical except this. And on the right here in green, we have the same function twice, but now it's a function of two variables. You can see it's x and n, where n is 1 and n is -2. Now, another way I was able to organize functions was, you can see here f of x, g of x. On the left, they have their own thing, but on the right side, they have the same trend. So what if I just take the right side and make that its own function? Then we can save a few lines of code there as well. We don't have to essentially write h of x twice. We can just invoke it once in each function. Okay, so moving to version 4, the main difference in version 4 was I was able to move black pieces now. Black pieces is really just using the same code I used for red. Obviously, moving different pieces. You're capturing different pieces. Pawns move the opposite direction. Version 5 was really similar to version 3, where I was optimizing. I combined red and black functions to be a function of the variables they already had, and also C, which stands for color, where I put 1 for red and -1 for black. Okay, so taking a look at the current version again, we can see the functions are very organized. I rearranged them in an order that was more intuitive, and I added these little descriptions of what each function does, so it's very easy to find. And of course, we can play games with both players, not just one, and everything works how it is intended. You can play chess in Python. Key takeaways from this experience. You have to balance between planning. Sometimes I would find myself planning too much, and I would not get started until I had everything set out perfectly, and nothing would get done. But sometimes I would go in with code with no plan, and I would regret it later. I would have to scrap it. Something else is to try new methods, and to not limit yourself to what you're used to. Even though there's like multiple ways to code the same thing, don't always try to use the same thing every time. Try out different functions. Give them a chance. You might like them. And of course, I highly recommend to enter this contest yourself. When you enter this contest, you can code whatever you want. You can code something you're interested in. You'll be more passionate about coding, you'll have a better mindset, you'll have more fun, and you'll learn a lot more. Overall, this contest is far more valuable than any other labs or lectures. Thanks for watching, and this was Eddie Chiang and his ENCMP contest submission.